Guys, welcome to my channel once again. Now we are going to discuss a topic called nozzles. Nozzle forms the exhaust system of gas turbine engines. It provides the thrust force required for all flight conditions. In turboprops, nozzle may generate a part of the total thrust. Main components are tailpipe, tail cone, and the exhaust duct. Nozzle could be either of a fixed geometry or a variable geometry configuration. Besides generation of thrust, nozzles have other functions too. Variable area nozzles are used for adjusting the exit area of different operating conditions of the engine. For thrust reversal, nozzles are deflected so as to generate a part of the thrust component in the forward direction, resulting in braking. For thrust vectoring the nozzle to carry out complex maneuvers. Exhaust noise control can also be done. Here we can see a schematic diagram of an fixed geometry nozzle, that is subsonic convergent nozzle and a convergent divergent nozzle on the bottom side. So here we'll be having main parts as tailpipe, nozzle and exhaust geometry. Here we can see a schematic of variable geometry nozzle, where we can see a dotted lined section which can be actuated. The exit of this nozzle can be actuated in that particular region. So here in first nozzle, that is subsonic convergent nozzle, here the exhaust of the nozzle, that is exhaust geometry of the nozzle, can be actuated in this particular manner, whereas in supersonic convergent divergent nozzle, or in this particular manner, we are going to expand the nozzle area so that we can increase or decrease the area of nozzle depending on our requirement. Here we can see major parts as tailpipe and variable nozzle. In convergent divergent nozzle, in order to gain supersonic conditions, there will be a section called afterburner. Afterburner section is developed, where after complete combustion of gases, we are going to add fuel into that combusted gases in order to increase the temperature and in order to increase higher amount of burning rates. Next, we'll go with types of nozzle. We'll be having convergent or converging diverging nozzles, axisymmetric or two-dimensional nozzle, and fixed geometry or variable geometry nozzle. We'll be having these three types of nozzles. Simplest is the fixed geometry nozzle. Convergent nozzle was used in subsonic commercial aircraft because here we can say it has a symbol, because there will not be any actuating parts, so that we need not to concentrate on actuating mechanism. Other nozzle geometries are complex and require sophisticated control mechanism. In order to have variable areas, we need to concentrate on those complex geometries. Nozzle must fulfill the following conditions. It should be matched with other engine components, and it should provide optimum expansion ratio, have minimum losses at design and off design, permit afterburner operation, provide reversed thrust when necessary, suppress jet noise and IR radiations, and also it should provide necessary vectored thrust. It should have minimal weight, cost and maintenance while satisfying the above conditions. Convergent nozzles are normally used in subsonic aircrafts. These nozzles operate under choked conditions, leading in complete expansion. This may lead to a pressure thrust. A convergent divergent nozzle can expand fully to the ambient pressure and develop greater momentum thrust. However, due to increased weight, geometric complexity and diameter, it is not used in subsonic transport aircraft. With this, we will be winding up the video. If you like the video, please do like, share and subscribe.